Firewall technologies, there are different types of firewall technologies depending on where the communication is taking place, where the traffic is intercepted in the network, and the state that is traced, and so on. So, if you can see the table, uh, this table contains the for each OSI layer, what kind of firewall technology is used. So in the physical layer, there is no firewall applicable. Data link layer, virtual private network, packet filtering is used. And the network layer, virtual private network, network address translation, packet filtering, stateful multi-layer inspection. Transport layer, packet filtering and VPN. Session, circuit level gateways, virtual private network VPN. Presentation VPN, application VPN, and application proxies. So VPN is used in almost all the layers, except in the physical layer. VPN is present in all the other 6 layers. So, so let's see what is a packet filtering. Each packet is compared with a set of criteria. Is it same as ACL? Not sure. So each packet is compared with a set of criteria before it is forwarded. Depending on the packet and the criteria, the firewall can drop the packet or transmit it or send a message to the originator. The rules can include the source and the destination IP address, the source and the destination port, the protocol used, TCP flag bits, direction, interface. Interface is used to check whether the packet is coming from an unreliable zone. It works at the internet layer of the TCP/IP model or the network layer of the OSI model. OSI usually it will be part of the router itself. This packet filter it will be part most of the time it will be part of the router itself. So next type of firewall is circuit level gateway firewall. This works at the session layer of the OSI model or transport layer of the TCP/IP. So packet filtering works on the network layer of the OSI model and the internet layer of the TCP/IP. But this circuit level gateway it works at session layer of the OSI model or transport layer of the TCP/IP. So the information at destination appears to have come from this gateway itself, as the incoming traffic carries the IP address of the proxy. So it gives the impression that the packet or the message has come from the gateway itself. So this monitors the session request from a source and then decides if it can be allowed to the destination. A circuit level gateway gives controlled access to network services and host requests. To determine whether a requested session is valid, it checks the TCP handshake between packets. Circuit proxy firewalls allow or prevent data streams. They do not filter individual packets. They're relatively inexpensive and hide the information about the private network that they protect. So after packet filtering and circuit level gateway firewall, we'll see application level firewall. So application level gateways can filter packets at application layer of the OSI model or the application layer of the TCP/IP. Incoming and outgoing traffic is restricted to services supported by the proxy. All other service requests are denied. So whatever is supported, what are the services that are supported by the proxy will be allowed. Other services will be dropped. Application level gateways configured as a web proxy prohibit FTP, Gopher, Telnet or other traffic. Application level gateways examine traffic and filter on application specific commands such as HTTP post and GET. Stateful multi-layer inspection firewall. Stateful multi-layer inspection firewalls combine the aspects of other three types of firewalls. That is packet. It combines packet filtering, circuit level gateways, and application level firewalls. They filter packets at the network layer of the OSI model or the internet layer of the TCP/IP to determine whether session packets are legitimate, and they evaluate the contents of the packet at the application layer. Application proxy. An application level proxy works as a proxy server and filters connections for specific services. It filter connection based on the services and protocols appropriate to that application. For example, an FTP proxy will allow only FTP traffic to pass through, and all other services and protocols will be blocked. Network address translation. NAT. Network address translation separates IP addresses into two sets and enables the LAN to use these addresses for internal and external traffic separately. It also works with the router, similar to packet filtering. NAT also modifies the packets the router sends simultaneously. Note, NAT can be in firewall as well. It has the ability to change the address of the packet and make it appear to have arrived from a valid address. It limits number of public addresses an organization can use. It can act as a firewall filtering technique where it allows only those connections which originate on the inside network and will block the connections which originate on the outside network. Advantages: NAT helps to enforce the firewall's control over outbound connections. It restricts incoming traffic and allows only packets that are part of current interaction initiated from the inside. It helps hide the internal network's configuration and thus lowers the success rate of attacks on the network or system. Disadvantages: the NAT system has to guess how long it should keep a particular translation, which is not always possible. The NAT interferes with encryption and authentication systems to ensure the security of the data. Dynamic allocation of ports may interfere with the packet filtering. VPN. Our VPN is a private network constructed using public networks such as internet. It is used for secured transmission of sensitive information over an untrusted network using encapsulation and encryption. I was thinking it does only encryption, but came to know that it does encapsulation as well. It establishes a virtual point-to-point connection through the use of dedicated connections. Only the computing device running the VPN software can access the VPN. So, firewall limitations. Firewalls can restrict users from accessing valuable services such as FTP, Telnet, NIS, etc., and they sometimes restrict internet access as well. Firewall cannot prevent internal attacks. Backdoor in a network. Example: a disgruntled employee who cooperates with external attacker. Firewall focuses its security at a single point, which makes other systems within the network prone to security attacks. A bottleneck could occur if all the connections pass through the firewall. A firewall cannot protect the network from social engineering and data-driven attacks, whereby the attacker sends a malicious links and emails to employees inside the network. If external devices such as laptops, mobile phones, portable hard drives, etc., are already infected and connected to the network, then a firewall cannot protect the network from these devices. The firewall is unable to adequately protect the network from all types of zero-day viruses that try to bypass it. A firewall cannot do anything if the network design and configuration is faulty. A firewall is not an alternative to antivirus and anti-malware tools. Firewall does not block attacks from a higher level of the protocol stack. A firewall does not prevent attacks originated from common ports and applications. Common ports examples are port 80 and 443. So it does not prevent attacks originating from these ports or applications like um, web application like HTML and a firewall does not prevent attacks from dial-in connections. Firewall is unable to understand tunneled traffic. So in the next video, let's see what is a honeypot.